Figure 215 comparison.java. In this example, we demonstrate command line input using Java's scanner class, which is capable of reading data type values from the command line. We begin at line 4 in this program with a so-called import declaration. Now, there's lots and lots of classes built into the Java class library that you can take advantage of in your programs. In the first program we looked at, we had used the string class in the parentheses of the main method definition to indicate that we had a string array of potential command line arguments being passed into the program, and we also used the system class's out object to output some text to the command prompt. Those two classes, string and system, are part of the java.lang package, which is available in every single program you create in Java. However, for all other classes, you're typically going to need an import declaration, which is what we're doing here at line 4. We're announcing to the compiler that we intend to use the scanner class from the java.util package, and if indeed we were using more than one class from this package, we could replace the class name scanner here with an asterisk character. Now, unlike some other programming languages, the import declaration does not bring any code into this source code file, for example, the way header files do in C or C++. Instead, it allows the compiler to load up this class, check it to make sure we're using it correctly, and give us any compiler error messages if indeed we're not using it correctly. Similarly, at runtime, this class will get loaded so that we can actually execute our program. Now, our class called comparison is going to perform the comparisons of two numbers inside of its main method, which starts down here at line 9. At line 12, you can see we're creating a scanner object. Now, the way the scanner object works is you have to tell it what stream of input you intend to read information from. In our case, we're taking advantage of a built-in stream, system.in, which is the standard input stream object, and by default it reads characters that are typed at the keyboard. And also it's predefined in the system class, so we don't have to create that stream object. As you'll learn eventually in Java, you have many different types of streams, including the ability to read from file streams or even network connected streams as well. So this system.in object is being used to initialize a new scanner object. Now this is actually creating an object in memory and calling its so-called constructor, which we'll learn more about in a subsequent part of this class, and we're initializing that scanner object with system.in. The resulting object is then assigned to the variable input, which allows us to interact with the scanner object. Now, as you will learn as we move forward, with the exception of the primitive type variables such as integers that we're about to look at, you normally are going to be required to use the new operator to create an object of any other type. At line 14 and 15, we declare two local integer variables, number 1 and number 2. And keep in mind in Java that all statements end in semicolons, as we did in the first program. These two variables will be used to store the results of the input from the user. At line 17, we prompt the user with the system.out.print method to enter the first integer. Now, in the first program, we used the println method. With the print method, this is going to position the cursor waiting for input just after the prompt enter first integer. At line 18, we obtain the first integer by invoking the nextInt method of the input object. So what it does is it takes in some of the characters that the user types at the keyboard and attempts to convert them into an integer. If the data is not in an integer whole number format, then something known as an exception will occur and an error message will print at the command line and our program will terminate. I'll show you that when I actually test the example. In later parts of the class, we'll introduce the concept of exception handling, at which point you'll be able to trap such problems and hopefully recover from them. So number 1 will be assigned the first integer typed by the user. At line 20, we prompt the user for the second integer, and at line 21, we invoke the nextInt method again on the input object to obtain the second integer. Some people in object-oriented programming like to refer to this as sending the nextInt message to the input object. Now once we have our two inputs, we have a series of if statements starting at line 23 and going through line 39 where we compare the values. For example, here at line 23, we compare number 1 and number 2 using the double equals equality operator, and at line 26 we have the inequality operator. We also have less than, greater than, less than or equal, and greater than or equal operators. These are your so-called equality and relational operators, and in each case, if the condition is true inside the parentheses of the if statement, and the parentheses are required, then the corresponding body will execute. And for us, the body is now using the printf method of the system.out object. Printf stands for print formatted, and in a printf call, you start with a format control string that indicates the formatting that you want to apply to the values being output, and also it provides placeholders for where those values should go. So for example, we have two placeholders here on line 24. Both of them say %d, which stands for a location where we intend to output an integer, and we haven't specified any other formatting yet. But basically what this means is that the first % specifier represents a placeholder for the value of number 1, and the second % specifier represents a placeholder for the value of number 2. And when we output the result, we'll follow that with a new line character as well. Now only 3 out of these 6 different if statements will evaluate to true for their conditions, therefore 3 of the system.out.printf lines should execute. Let's go ahead and take a look at a sample execution. We'll do this from the command prompt in this example. Before we do that, we have to compile our program, and remember, to compile from the command line you can use the javac command followed by the complete name of your .java file. Once you do that, you'll get a .class file, and again recall that when you run your program you do so without the .class extension. So here we'll run the comparison program, and it prompts us to enter the first integer. So I'll type 100, and let's say we type 200 for the second integer, and you can see that 100 is not equal to 200, 100 is less than 200, and 100 is less than or equal to 200. Now recall that I mentioned if you don't type a real integer value that can cause something named an exception in your program. So watch what happens when I run this again, and instead of typing an integer I type hello. Then you see what's known as an exception stack trace displayed at the command prompt here. And this is an interesting bit of information because it tells you where the problem occurred in your program. First thing it tells you is that an exception occurred, in this case in the main thread of execution, which is where our main method gets called. And the type of the problem was a java.util.input mismatch exception, and what that means is that the type of input I was looking for did not match up with what the user actually typed at the keyboard. Now the rest of this is a so-called stack trace indicating everything that was on the function call stack at the time that this problem occurred. Now the way you want to read these stack traces for now is you want to scan from top to the bottom looking at each individual @ line and specifically looking for something that came from the code that you wrote, because chances are when you get an exception as a result of calling a library method, it's because you provided incorrect input somehow to that method. So as you look down, you see that the first 4 @ lines are all referring to pieces of the scanner class. But at the 5th line it says that the problem occurred in the comparison class's main method in the file comparison.java at line 18. Now remember, we typed hello in response to the first prompt. So let's go back to our code for a moment, and if you look at line 18 here, you'll see that this is where we were attempting to read the first value. Now these exception stack traces are designed not only to help you find the problem in your source code, but also hopefully to help you understand where you'll eventually need to use exception handling in your code. And this is something we'll focus on as part of the second course in this video course series.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.